Good day, good day, good day, everyone. Good day, everyone. My name is Vuyani, and today we'll be doing mathematics paper 1, and we are proceeding from where we left from last week. Today we'll be doing number patterns. Let's just wait for maybe 2 minutes so that few people maybe can join in and join us. Please don't forget to subscribe. Don't forget to hit that like button. Please don't forget to hit that notification button. Also, please don't forget to comment so that we can get feedback from you. Welcome everybody. Let's get the ball rolling. As I said earlier, today we'll be doing number patterns, and we'll be covering grade 11 and grade 12 stuff. Now on number patterns, I want us to have an overview of when we say number patterns, what are the basic things which we look at. What are the basic main topics which we look at in number patterns? So the first one, we have what we call arithmetic sequence or the linear sequence. Number two, we have what we call the quadratic sequence. And number three, which is the last one, which is taught in grade 12, which is the last one. Now, without wasting much time, let me just give you an overview on the first one, which said the linear sequence or the arithmetic sequence. Now, on an arithmetic sequence, we have the first constant difference. In other words, in the sequence which we are given, we only have the first difference. We have the first difference which is the same. In other words, maybe for instance, we are given 2, 4, 6, 8, 10. So when we say 4 minus 2, we get positive 2. When we say 6 minus 4, we get positive 2. When we say 8 minus 6, we still get positive 2. So in other words, we have a constant first difference. So now, this is what is so important that you have to understand under the arithmetic or the linear sequence. Also now, the constant difference is represented by the letter D. Constant difference, which means it is the same. Now, in order for us to find D, it's always the case that it's T2 minus T1. T is representing term. So we're saying the term number 2 minus term number 1. Also, which is the same as term number 3 minus term number 2, which is also the same as term number 4 minus term number 3. And proceeding in the same manner, in the same sequence. This is what is so important. Now, the final thing which is important on the linear sequence is that we have the general term or we have the nth formula, which is called Tn is equal to a plus n minus 1 times d. Now, where a is the first term, it is the first term in the sequence, and d, we have said it earlier that it is our constant difference. So now we have highlighted that this is what is so much important, what we call our general formula or our general term. Now we have to know that the a is representing the first term which we are given in the sequence, and d is the constant first difference. Now, number 2, we said about the quadratic sequence. Quadratic sequence. Now, the quadratic sequence has the second constant difference. So that's the difference between the first, the arithmetic and the quadratic. It is that the first one, the linear sequence, has the only first term. It only have the constant difference, the first constant difference, whilst this quadratic sequence has the second constant difference. Now, what is also important was this one is the general term, or the nth formula. So on the nth formula, we know that we have Tn is equal to an squared plus bn plus c. So now, okay, so now in order for us to get the values of a, b, and c, we have this small set of equations. So in order for us to get a, we use this equation 1, which is 2a is equal to d. We say that a, so that we can get the value of a in the general form, and d, we know that it is representing the second constant difference. Then number 2, in order for us to get the value of b, we say 3a plus b is equal to term 2 minus term 1. Then the third one, in order for us to get the value of c, which means the value of a which we found in the equation 1 here, we replace it here in this equation so that we can get b. Then now, in order for us to get c, we will say a plus b plus c. Then after that is equal to t1. Then after that, we'll be able to get our first term. We'll be able to get our value of c, since we have already calculated the value of a and the value of b. So this is basically our quadratic sequence. Going to the third one, which is called the geometric sequence, which is in grade 12 now. So the geometric sequence, it has what we call a constant ratio. It has what we call constant ratio, which is denoted by the letter r. So how do we find r? R is always equal to term 2 divided by term 1, which is the same as also term 3 divided by term 2, which is also the same as term 4 divided by term 3. So that's how we find our r. It's a constant ratio. Now, the general term of a geometric sequence, the general term is Tn is equal to a r n minus 1. This is our general term. So in other words, we only need A, and we say that A is representing the first term in our sequence. And R, we said it is representing the constant ratio. Said it is representing the constant ratio. It is representing the constant ratio. Now, we are done. I was just giving you an overview. So, to just go through it again, we say that we have three things which are important, three topics, three subheadings. The first one is the arithmetic or the linear sequence. And we said under the linear sequence, we have the first constant difference. In other words, when we subtract term 2 minus term 1, we get the same equal difference in the first difference. Then we go to the quadratic sequence. We say that this one has the second constant difference. So in other words, the first difference when we subtract our terms which we are given in the sequence are not constant. So we have to subtract again so that we can get a second constant difference. So in other words, when we are saying that we are getting the second constant difference, we are saying that now if we look at it in another view, we are saying that the first difference is just a linear sequence. In other words, then after that we have the geometric sequence, which is done in grade 12. Now this one, we say that it is the easiest one actually. Why? Because on this one, it's only that you have to know the constant ratio, which is represented by R. And for you to find the constant ratio, it's always term 2 divided by term 1, which is equal to term 3 divided by term 2, which is equal to term 4 divided by term 3. So it's always the case. It's always the case that you have to know these important things. Now, going to our today's question paper. Now, we are given question 3. We are given question 3. So basically here we are given that given the finite linear pattern, which is 12, 17, 22, and 172. Now, this is the key term which we have to look at in this question. We are given that given the finite linear pattern. So now, what is important and what we have to take care of here is linear pattern. And we know that a linear pattern or a linear sequence, it has the first constant difference. It's always the case and it will never change. It will always be like that. So now we are given this sequence now. So since we are given this sequence, calculating 3.1.1, we are asked to determine a formula for the nth term of the pattern. We have to underline the key term, the nth term. We have to determine the nth term. So we know that Tn is equal to A plus n minus 1 times the constant first difference. What is our A? So we can just write here, say given our A will be our first term, and in this case our first term is 12. And what is our D? Our D in this instance, is supposed to be term 2 minus term 1. We said that earlier. So our term 2 is 17 minus term 1, which is 12. Then 17 minus 12, you get your answer, which will be 5. So now we have A and we have D. This is not necessary, which I just wrote right now. This is not necessary. It is for you to understand, to have a clear view that where is our A coming from. Our A is the first term which we are given in the sequence, and our D is the constant difference, which is the constant first difference when you subtract term 2 minus term 1. Now, moving forward now, so now They said calculate the nth term. That's easy. We know that Tn is equal to, what is our A? We said our A it's 12 plus n minus 1. And what is our D? Our D it's 5. Then after that we simplify this. Simplifying this is going to be 12. Then 5 times n it's 5n. 5 times negative 1 it's negative 5. We know that these two are like terms, so we'll be left by 5n, then 12 minus 5, and we get our positive 7. And we get our positive 7. So our nth term or our pattern, it's 5n plus 7. So you only have to know what is your A and what is your constant difference. So now you'll be able to detect or to be able to calculate your nth term or your nth formula. Now, we are given now on number 3.1.2. They are saying calculate the value of T12. So in other words, we said that earlier on in 3.1.1, we said that we have calculated our Tn and we find out it is 5n plus 7. Now, they are saying that calculate T12. So in order for you to calculate T12, that's easy already. Why? Because they are saying T12. So in the position of n, of this n, they have replaced by 12. So that won't be hard, because wherever we see n on our nth formula or on our general formula, we will substitute by the subscript here, which is 12. So we're going to say 5 times 12 plus 7. Then 5 times 12, it's 60. 60 plus 7, and you get your 60, your 67. So that will be our answer. That will be our answer. Please don't hesitate to ask question in the comment section. Please, you can even find us on Zoom. You can call in on Zoom. You can also ask us on our WhatsApp group, which is Yebo Tutor. Please don't hesitate so that you can be able to interact. Now, going to number 3.1.3. Determine the number of terms in the pattern. 3.1.3. So whenever they say that determine the number of terms in the pattern, we must have our general term or our nth formula. Then after that, we also have to have the last term which we are given in the sequence. So in this case, our last term which we are given in the sequence, it's 170, 172. So when they say determine the number of terms, you have to say that Tn, which we know that is 5n plus 7. So now Tn must be equal to the last term in the sequence. So in this case, it's going to be 5n plus 7, which is equal to, what is the last term in the sequence? We have 172. Then after that, we have to calculate for the value of n. 5n will be equal to 172 minus 7, because we transpose positive 7, and when positive 7 is transposed to the right hand side, it will subtract since it is positive. Then we have 5n, which is equivalent to 165. Then we only need n, not 5n, so we divide both sides by 5, we divide both sides by 5. Then we have our n to be equal to 33. So how many terms are in this pattern? There are 33 terms. There are 33 terms. We have 33 terms in this pattern. We have 33 terms in this pattern. Please don't get afraid to ask question. I have a question on the comment section that how can I tell if it's a arithmetic or a geometric sequence for the first time when I see one. So always when you look at your equation, I always advise check. Even in this question, they said in this sentence that given the finite linear pattern, they've already highlighted that this is a linear sequence. This is a arithmetic sequence. They've already highlighted it for you. It's an arithmetic pattern it's already highlighted. Or you can now subtract now, because we know that we have three things which we talk about when we talk about number patterns. We talk about the linear, the quadratic and the geometric. The linear one, we have the constant first difference. So you can even check on your terms that do you have the constant first difference. When you say, maybe for instance in this question, 17 minus 12 and 22 minus 17, do you get the same answer? If you get the same answer, then after that you see that no man, this is a linear pattern. Now if you are not getting the same answer in that question, for instance maybe you were given 3, you were given 6, you were given 12. So when you're given something like that, you can even check. When you say 6 minus 3, you get 2. Sorry, 6 minus 3, you get 3. Then when you say 12 minus 6, you get 6. There is no constant difference there. Then maybe for the third term which we have, it's 18 for instance. So when you say 18 minus 12, you get what? You get 18 minus 12, you get 6. Now we can see now when we subtract on the second, now on this first linear equation now, which we are having 3, 6 and 9. When we say 6 minus 3, we get 3. Now we already see that since the first difference is not the same and the second difference is the same, then now we'll be able to also to detect that this is a quadratic pattern. Also now, if it is a geometric, you see it by when you say maybe you are given 3, 6. When you say 6 divided by 3, you get 2. When you say 12 divided by 6, you get 2. So you have a constant ratio. When you divide term 2 divided by term 1 and term 3 divided by term 2, and you get the constant or the same answer, we will automatically know that we have a constant ratio. I hope I answered you, Tim. Now, let's move forward to 3.2. Let's move forward to 3.2. Now, on 3.2, given the first 4 terms of linear pattern, 3 is to x, is to y, and is to 30. Given the first 4 terms of the linear pattern, so now we just have to underline the fact that we were told that this is a linear pattern. And we know that on the linear pattern, we have the first constant difference. So since we have the first constant difference, that won't be hard. Even if we are given algebraic letters in this term, we know that it has to be x minus 3. And we know that it has to be y minus x, because this is term, this is term T1, T2, T3, T4, and we know that our constant difference is always this minus this, and recurring T3 minus term 2. So now we are here now, so it's going to be 30 minus y. We know that the constant difference of a linear pattern are the same, so we can automatically say that x minus 3 is equal to y minus x. Then after that, you can solve this simultaneously. So now when we transpose x to this side, we're gonna have 2x minus 3 is equal to y. Then we can say this is our equation 1. Then now we can take these two now. 30 minus y is equal to y minus x, because we say that we always have the constant first difference, which means T2 minus T1 is equal to T3 minus T2 is equal to T4 minus T3. So since now we are dealing with algebraic letters x and y, and we are told to calculate the values of x and y, we will solve it in this way, that we say that the constant difference between term 2 and term 1 must be equal to the constant difference between term 3 and term 2. So in this instance, let's solve in group like terms. 30 plus x is equal to y, and when you transpose that y, is going to be 2y. Then this can be our equation 2. So since we have equation 1 and it's only y, so we can substitute 1 into 2. So wherever we see y, we will substitute by the 2x minus 3. So we're going to say 30 plus x is equal to 2x plus 2x, where is this? 2x minus 3. Now we know that it's 30 plus x which is equal to 2 times 2, we get 4x, and 2 times negative 3, we get negative 6. Then we are solving for s in this case. So we can say 30 plus 6, which is equal to 4x minus x. Then 30 plus 6 is going to give us 36. Then 4x minus x, we're going to get 3x. Then when we solve for x, we divide both sides by 3. We divide both sides by 3. Then we get our x value to be equal to 12. But you are not yet done, because they say calculate the value of x and the value of y. So now for the value of y, it's now easy. Now we will substitute x is equal to 12 in equation 1, since we already know that our equation 1 is saying that 2x minus 3. So wherever we see x, we have to insert 12 there. So we're going to have y, which is equal to 12 minus 3. Then we get our y value, because 2 times 12 it's 24, and 24 minus 3 it's 21. So now you can conclude and say, therefore your x will be equivalent to 12, and your y will be equivalent to 21. So in other words, you have solved this simultaneously. You have solved this question simultaneously. Any question before we move forward? Any question before we move forward? Any question before we move forward? Okay, let's move forward then. Now we're gonna do our question 4 now. We're doing our question 4 now. Question 4. So now they are saying, given the quadratic pattern, they have already told you, given the quadratic pattern. So the moment you hear the term given the quadratic pattern, now you already have to know that this has a second constant difference. So now 4.1, write down the next term of the pattern. Write down the next term of the pattern. We are given 244, 193, 148, and 109. So we have to calculate the next term, 2 marks. So this is a quadratic pattern. So since it is a quadratic pattern, we know that it has a second common difference. So first we're going to say T2 minus T1. So 193 minus 244, we get negative 51. Then when we say 148 minus 193, 148 minus 193, we get negative 45. When we say 109 minus 148, we say negative 39. Bear in mind, I am not saying 148 minus 109, since 148 is bigger than 109. It's always that the term 2 minus term 1, or term 3 minus term 2. It's always the case. It doesn't change. It is always the case that you subtract in that manner. It's not because 244 is greater than 193, so you decide to say 244 minus 193. You have to say 193 minus 244. In other words, T2 minus T1. And also when you come on this one, you say T3 minus T2. It's always the case that you have to do that. And you can see that this is now our first difference, but the first difference is not the same since it is a quadratic pattern. Now we have to find our second constant difference. When you say negative 45 minus 51, we get positive 6. Now coming again, when you say negative 39 minus 45, we get positive 6. You see, now we are having a constant difference. So as well here, we must have a constant difference. So when we say this minus this number minus 39, we must get 6. And that number will be negative 33. Because, let me just do this so that you can see. Because when we say that we have to say this, let's just say this is our x. So when we say x minus 39, we must get 6, because 6 is our constant second difference. So x plus 39 is equal to 6, and x will be equal to 6 minus 39, which is the same as negative 33, which we have here. So I'm trying to show you how we get negative 33. We say that the second difference of a quadratic pattern is always equal. It is always equal. But still, we have not yet answered our question. We need this term. We know that this term minus this term is equal to this term. So in other words, maybe let me just put y there. So if you don't understand it clearly, so we have to say y minus 109 must give us negative 33. So when we say y is equal to negative 33 plus 109, we will get that y to be 76. So in other words, the term which is supposed to be here, it's 76. It's 76. So this, I just did this so that you can see where we are getting this value. So this is how you determine the next term. You have to know the constant second difference. Then after that, you can now start and going back now and doing some formulas so that you can be able to get the next term. Moving forward to our question. To our question 4.2, determine the formula for the nth term. This one is going to be a bit long. So now, in order for us to determine the formula for the nth term, we know that Tn of a quadratic pattern, is always equal to an squared plus bn plus c. So now we have to find these values of these constant or these coefficients. We have to find them. So how do we find a? We say that 2a is equal to constant difference. We calculated the constant difference to be 6. So we're going to say a will be equal to d divided by 2. And what is our d? Our d is the constant difference, which is 6 divided by 2, and we get our a to be positive 3. We get our a to be positive 3. Now we want the value of b, and we know that in order for us to find the value of b, we use this equation that 3a plus b is equal to term 2 minus term 1. We have already calculated the value of a to be 3, so where we see a, we replace by 3 plus b. And what is term 2 minus term 1? Term 2 minus term 1, we get negative 51. Then our b will be equal to negative 51 minus 9, because this is positive 9. Then your b will be equal to negative 60. Easy. You are not given these formulas in the exam. This one, that 3a plus b is equal to term 2 minus term 1. So please, you have to know it by head. Please make it a point that you know it by your head. Please make it a point that you know it by your head. Then in order for us to calculate our value of c, we know that a plus b plus c is equal to our term 1. What is our a? Our a is 3. What is our b? It's negative 60. And now we want the value of c, and our term 1 is T44. It's 244. We know that from our equation. This is term 1, term 2, term 3, term 4. So basically our term 1 is 244. Our term 1 is 244. Now we make c the subject of the formula. C will be equal to 244 plus, because 3 minus 60, it's negative 57, and negative 57, when we transpose to the right, it will be positive 57. Then we use our calculators. 244 plus 57, we get 301. Then therefore, our Tn will be equal to 3n squared minus 60n plus 301 plus 301. So this is our Tn. So first things first, you have to know the second constant difference. Then you calculate the variable, the value of A. You calculate the value of B, and lastly you calculate the value of C. Then after that you substitute them in your equation. Okay, great. Now doing 4.3, please don't hesitate to ask any question if you have one. We are available on our group as well. Please don't hesitate to ask. Okay, on 4.3, which term of the pattern will have the value of 508? The value of 508. The value of 508. So in other words, we are already given, it's 4.3. We are already given that Tn must be equal to 508. What is our Tn? Our Tn is the equation which we have already solved. Our Tn, it's the general formula or the nth pattern or the nth term of the sequence, which is 3n squared minus 60n plus 301 equal to 508. Then after that you solve and transpose 508 to the left hand side, and since it is positive, when it goes to the left hand side it will be negative. So we're gonna have 3n squared minus 60n plus 301 minus 508, which is equivalent to 0. Then these are alike terms. So what we do now is we're gonna say 3n squared minus 60n. Then using your nice calculators, 301 minus 508, using your nice calculator. When I used mine, I got negative 207 equal to 0. So now, going back to solving for x, which we did last week, if you are in now this situation, which is a quadratic formula, which is a quadratic equation, just like this one, I advise, if you are not good in finding factors, please use the quadratic formula. It is always straight and direct. So what does the quadratic formula says? It says that x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. We know in this situation we are not talking about x, we are dealing with n. So after you are done writing this equation, write n, because this is what we are calculating. Our b, we know that this is our a, this is our b, and this is our c. Always, I'm going to repeat this again, always take the sign. Go with the sign. B is negative 60. Don't just say, since in front there's a negative, I want to put negative 60. Please, I advise that put that negative 60 inside bracket, because it has already have a difference. Plus or minus square root of negative 60 all squared minus 4. What is our a? Our a is 3. Our c is negative 207 all divided by 2a, and our a is 3. Using your calculator, you're gonna get two straight values. And when I'm using my calculator, I got n is equal to 23, or n is equal to negative 3. But now we have to conclude also in this one. I cannot come in a class, maybe you are 40, then I say count numbers, then I start negative 1, negative 2, negative 3. So which means you don't exist or something. So we can't deal with negative numbers. So in this case as well, we have to take the positive sign, the number which is positive, because when we are counting people, we count them positively. 1, 2, 3, 4, 5. So in this instance as well, we take the positive number. So we can verify and say that therefore our n will be equal to 23. You have to conclude and say therefore. So since you have be able to conceptualize that this is what I have, and this is this real scenario which we're going to apply. Now we are going to 4.4. This is where you're supposed to get some marks. 4.4. 4.4. Between which two consecutive terms of the quadratic pattern will the first difference be 453? So already, for the fact that they've already told that the first difference will be 453, which means they've already given us Tn, which is equal to 453. Now, the first difference, we know that the first difference, your mind has to come and say, no, first difference is the arithmetic pattern, or is the arithmetic sequence. So the formula of an arithmetic sequence is a plus n minus 1 times d is equal to 453. What is our a? It's negative 51, because we said the first difference. You see, you still remember on our original equation, this was our first difference. So we are talking about this. This is our first difference. So this is going to be our value of a, because this is the first difference, and the difference, constant difference, is going to be positive 6. Going to be positive 6. So on the value of a, we'll put our negative 51 plus n minus 1 times 6 equal to 453. Now we have to solve for n. We know that negative 51 plus 6n minus 6 is equal to 453. Then our 6n will be equal to 453 plus 57, then we get 510, because we transpose these two to that side, which is the right side, because we are grouping the like terms. Then after that, we only want n, so we divide by 6, we divide by 6, then you get your n to be equal to 85. Don't worry yourself, use your calculator, and your n will be equal to 85. So they said we have not yet finally answered the question, because in the question they said that between which two consecutive terms of the quadratic pattern will the first difference be 453. Two consecutive terms. We have already found one. So now we know that when n is 85, we know that now we have to find another consecutive term where we'll be able to certify what the question has asked us. So now, between these two terms, now you can now verify that between, you can increment by 1, 85 and 86. So between these two terms, we can be able to find the first difference, which will be equivalent to 453 between these two terms. Between these two terms, this is where you have to grab all those marks. The questions are still not that bad. Now, doing 4.5. On our 4.5, we are told that show that all the terms of a quadratic pattern are positive. So in other words, we have to show that our general formula is positive, because that's the only way we can show that the quadratic pattern is positive. So in other words, it must be greater than 0. It's always the case that in order for us to prove or to show that they are they are positive, there must the general term must be greater than 0. They must be greater than 0. So we know that our Tn is equal to 3n squared minus 6n and plus 301. And we know that if we solve this and make this TP formula with this, when we are talking of functions, which we'll be doing next week, the TP formula, we can convert this standard form into TP formula. So we can solve this by completing the square so that we can have our equation, which will be in this sense that it will be n minus 10 all squared plus 1. Now, let me just remove this, and this must be greater than, equal to, like this. So in other words, you have completed the square and you ended up having this standard. Completing the square, this was taught in grade 11. You complete the square, and after that you get this TP formula, or the turning point formula. That's what we say in functions. Then now we are not yet done. Now moving forward now, therefore this means that the T is a minimum. It is a minimum valued function. It is a minimum valued function with minimum value which is 1. With the minimum value which is 1. So therefore we can now say that, because if we are not going to determine the range of this parabola, because this is a parabola, determining the range of this, it will be, let me just write that the range, it will be T is greater, or the range of T, sorry, the range of T, it will be Y must be greater or equal to positive 1. So as you can see that these are positive numbers. As we can see that these are positive numbers. Sorry, these are positive numbers. So initially we are given our general form, or we have calculated our general form. Then after that, this is a standard form when we talk of functions. This is a standard form in functions formatting. So we change this from standard to the turning point format. Then we have 3 open bracket n minus 10 squared plus 1. We completed the square so that we can end up being here. We know that the TP formula, let me just write something so that maybe don't get confused. So TP formula for parabola, we know that y will be equal to a x minus p all squared plus q. So you complete the square if you are given in this standard formula. So basically, why did we do that? So that we can have the range. So when we have the range, it will determine either the graph is like this or is like in this format. But we'll talk more about functions next week. So in this question which we are given, that show that all the quadratic terms in this sequence are positive. So in order for you to show that, you just have to be able to realize what is the range. So we are saying that T is minimal valued function with minimum value which is equivalent to 1. So this is what is also as well important. So it's always the case that we have to realize something like that. Now we are done with number patterns for grade 11. We are done. We're going to take a short break of approximately 3 minutes. Then after that, we come back. We do number patterns for grade 12s. Bear in mind that the number patterns are the same. The linear and the quadratic, they are the same, even in grade 12. So please, if you have any question, please don't hesitate to ask any question in the comment section, or you can even ask on our group. We are willing, we are so much willing to assist you in the group. We are so willing to assist you in the group. We're going to take a small break right now for 5 minutes. Then after that, you're going to come at 1640, then we do the final lap and we are done for the day. Thank you. Welcome back, welcome back, welcome back. We're gonna do our last question right now, which we have adapted from grade 12, number patterns as well, 2017. Welcome for our last final lap. Now, on question 2.1, question 2, number patterns, question 2. Okay, cool. Now, on question 2, we are given the following quadratic number pattern. Now, we are already gonna highlight the important part, which is written quadratic number pattern, which means when we have already seen that we are given that quadratic number pattern, now we have to know that on a quadratic pattern, we have the second constant difference. On the quadratic number pattern or on the quadratic sequence, we have the second constant difference. It is always the case that we have the second constant difference, and we always know that in order for us to have our Tn or our nth term, we calculate it by saying an squared plus bn plus c. Then now you will have to calculate the value of a, the value of b, and the value of c, so that you can be able to have your formula, your general term. Now, in our question, we're given this sequence 2.1.1. We are given 5 is to negative 4, negative 19, negative 40. So how will you solve that? They are saying that determine the constant second difference of the sequence. So in other words, we want the second constant different. So negative 4 minus 5, it's negative 9. Then we go negative 19 minus 4, it's negative 15. Now negative 40 minus negative 19, we get negative 21. So this is our first this is our first difference. But they didn't ask the first difference, they want the second. They want the second difference, because a quadratic pattern have the constant second difference. So negative 15 minus 9, we get negative 6, and negative 21 minus 15 minus 15, we get negative 6. So therefore, our d, which is the constant second difference, will be equal to negative 6. So that's how you calculate and answer that question. That's how you calculate and answer that question. Now, moving, determine the nth term of the pattern. This is a quadratic number pattern. So since it is a quadratic number pattern, it won't be hard, because we know that in order for us to determine our nth term, we just have to say Tn is equal to an squared plus bn plus c. So how do we find our a? We have done that early. We know that 2a is equal to d, and our a now will be equal to d over 2, and our d, which we calculated in 2.1.1, it's negative 6 divided by 2, and we get negative 6 divided by 2, it's negative 3. Now we have to calculate the value of b. We know that in order for us to calculate the value of b, we use the equation 3a plus b is equal to term 2 minus term 1. Then our a, we have calculated it here, and it's negative 3 plus b is equal to term 2 minus term 1. We calculated it here when we say t2 minus t1, and we get negative, we got negative 9, sorry. So we have negative 9. So our b now will be equal to negative 9. Then 3 times negative 3, it's negative 9. And when it transposes the negative 9 to that side, it will be positive 9. Then we'll end up having b, which is equivalent to 0. Now we have to calculate the value of c. In order for us to calculate the value of c, we know that a plus b plus c is equal to term 1. What is our a? Our a is negative 3, our b is 0, and we want to calculate c given the t1, which is 5. So making c the subject of the formula, c will be equal to 5. This is a negative 3. When we transpose negative 3 to the right hand side, it's going to be positive 3. Then we get c to be equal to 8. Then therefore our general term Tn will be equal to negative 3n squared. Our b is 0n plus 8, and we know that 0 times anything is 0, so there is no need for you to write 0n here. So we can just say that our answer, our final answer, it's negative 3n squared plus 8. It's negative 3n squared plus 8. Negative 3n squared plus 8. Negative 3n squared plus 8. Thank you. We are done determining the nth term. Now the following question is asking us to determine which term of the pattern will be equal to negative 25,939. So we know that the moment they say which term of the pattern will be equal to, so we already know that Tn must be equal to negative 25,939. We already know that because they are saying which term of the pattern will be equal to negative 25,939. So we have calculated our Tn to be negative 3n squared plus 8 and must be equal to negative 939. We transpose 8 to that side, we're going to have negative 3n squared, which is equivalent to negative 25,000, because this is a positive. When it goes to that side, it's going to be a negative, so we're going to have 947. So we're going to have negative 25,947. We divide both sides by negative 3, divide both sides by negative 3, then we're going to have n squared, which is equal to cancel, and we're going to end up having 8,649. You use your calculator always. Then we want n, not n squared. So what are we supposed to do? We square both sides so that you have plus or minus. Then this and this will cancel each other. Then our n will be equal to plus or minus 93. But now you have to verify now and confirm your answer now and say your n final will be equal to positive 93. It's always the case that your n must be positive whole number. It cannot be 3 over 2. Even if it's a positive 3 over 2, your n cannot be positive 3 over 2. It's always the case that it has to be positive whole number. So our positive whole number is positive 93, because in this case we're having n which is equivalent to plus or minus 93. This is the same as n is equal to negative 93 or n is equal to positive 93. This is the same thing. Then now we just have to finalize and say our n must be equal to positive 93. Thank you. Now, please don't hesitate to ask any question if you have one. Now we are doing number 2.2. Now, in grade 12, we have arithmetic sequences, and we also calculate the summation. We have what we call summation in grade 12. So in the summation part of grade 12, this is where they can be at least bit rough a little bit, but it's not that hard. But let's go. The first 3 terms of an arithmetic sequence are, we already taught arithmetic sequence, so we already know that we have the first constant difference. So we are given that 2k minus 7, also given that k plus 8, also given that 2k minus 1. Then now they say calculate the value of the 15th term of the sequence. So firstly, we are given this sequence. So now let's calculate the value of k so that we can have values. So in order for us to calculate the value of k, we know that k plus 8, this is term 2, this is term 1, this is term 3. So term 2 minus term 1, so it's going to be minus 2k minus 7. Then also term 3, which is 2k minus 1 minus k plus 8. So k plus 8 minus 2k, then negative times negative is positive 7. Then this side we're going to have 2k minus 1. This times this, we're going to have negative k, negative times positive k, 8, negative 8. Then solving this side, we're going to have negative k plus 15. And this side, we're going to have k negative 1 minus 8 is negative 9. So since this is a quadratic, since this is a arithmetic sequence, we know that the difference, the first common difference is equivalent to each other. So negative k plus 15 is equivalent to k minus 9. It's equivalent to k minus 9. It is equivalent to k minus 9. So making k the subject of the formula, we can say 15 plus 9 is equal to k plus k, because we transpose this k to this side and transpose the negative k to that side. Then 15 plus 9, 15 plus 5 is 20, plus 4 is 24, which is equal to 2k. We only want k, so what do? We divide both sides by 2. We divide both sides by 2. Then we have our k to be equal to 12. So our k will be equal to 12. Now, let's have our sequence now. We were given that 2k minus 7. We're also given k plus 8. We're also given 2k minus 1. So now we already know the value of k. So since our value of k is 12, we substitute here so that we only have values and remove the algebraic letters. So it's going to be 2 times 12 minus 7, 12 plus 8, and 2 times 12 minus 1. So 2 times 12 is 24. 24 minus 7, it's 17. Then 12 plus 8, it's 20. Then 2 times 12 is 24 minus 1 is 23. So this is our sequence. This is our sequence. Okay, now we were told and we are asked to calculate the value of the 15th term. So in other words, we want T15. Okay, and we know that since this is an arithmetic sequence, we always know that our Tn will be equal to a plus n minus 1 times our constant difference. So what is our constant difference in this case? What is our constant difference in this case? What is our constant difference in this case? We know that constant difference d is t2 minus t1, which is 20, minus 17, which is positive 3, which is positive 3, which is positive 3. And a, we know that a is the first term of the sequence. So therefore, we can say Tn will be equal to 17 plus n minus 1 times our constant difference, which is positive 3. We are asked to calculate T15. So we want T15. So wherever we see n, we replace with 15. So it's going to have 17 plus 15 minus 1 times 3, which will be 17 plus, this is 14 times 3. Then we use our own calculators. Then we get 59. So our 15th term is 59. Just to go through it again, we were given 2k minus 7, which was our term 1. And we were given also k plus 8, which was term 2. And we were also given 2k minus 1, which is our term 3. So now we know that this is an arithmetic sequence. And in an arithmetic sequence, we always know that there is a first constant difference. So in other words, we know that our d is always equal to term 2 minus term 1. So this was our term 1, this was our term 2, this was our term 3. So basically we said our T2 minus term 1 and our T3 minus term 2 minus, don't forget this minus, it is subtracting the entire term 1, not only 2k but the entire. Then after that we subtract, then we ended up having the difference here to be negative k plus 15, and the difference on this side to be k minus 9. And we know that it has equal constant difference. So in other words, this difference is the same. So negative k plus 15 will be equivalent to k minus 9. Then we solve for the value of k. Then we were able to find our k to be equal to 12. After we find that our value of k is 12, we substituted the value of k in the original sequence or in the original pattern which we are given above, and we ended up having 17 is to 20 is to 23. So basically this is our pattern. Now we know that this is an arithmetic sequence, and an arithmetic sequence, in order for us to determine the general term or the nth term, we say Tn is equal to a plus n minus 1 times the constant difference, where our d is the constant difference, and we calculated it by saying term 2 minus term 1. Then we got positive 3. Then we have our a, which is always 17. But now we were told to calculate the 15th term. So what is our 15th term? Our 15th term is T15. It is T15. So our T15 will be equal to, so wherever we see n, because since this is our general equation, now wherever we see n, we have to replace by 15. So we saw n, then we replace by 15. Then we ended up having 17 plus 15 minus 1 times 3. Then after that, we say 17 plus 14 times 3. Then we get our positive 59. Please, if you have any question, feel free to ask. Please, if you have any question, feel free to ask. Okay, let's move forward. We are about to be done. We're about to be done. We are doing the last question now. 2.2.2. Calculate the sum of the first even terms. Underline that term, even terms. Calculate the first sum of the even terms. Now, we know that our sequence will be 17 is to 20 is to 23, and the difference is 3, so it can be 26, it will be 29, it will be 32, etc., etc., since our constant difference is positive 3. So basically this is our sequence. So now the question is saying to us, calculate the sum of the first even terms of the sequence. Even terms. Now, in this, our even terms are numbers which are divisible by 2. So the even terms will be 20, that will be the first term. The second term will be 26. The third term will be 32, etc., etc. These are even terms of the sequence. Let's check the common difference. 26 minus 20 is 6. 32 minus 26 is also 6. So we have the constant first difference, which is positive 6. Now, they want the sum of the first 30 even terms. We know now we have this nice formula for calculating the sum of an arithmetic sequence or an arithmetic series. When we are having these, when we are asked questions about a sum, we are talking about the arithmetic series because it's a summation of terms. So now it's going to be n over 2, 2a plus n minus 1 times d. Now, n is representing the number of terms. So now our question is calculate the sum of the first 30 even terms. So now we want the sum of 30 even terms. So wherever we see n in our equation, we will replace by 30. So we're going to have 30 divided by 2. Then what is our a? Our a in this now case is 20 because we want the sum of the first 30 even terms which are located in this sequence. So our first term now will be 20 plus our n, we said it's 30 minus 1. And what is our d? Our d is 6. Our d is 6. Our d is 6. Then we use our calculator. We know that 30 divided by 2 is 15. We know that this is 40. This is 30 minus 1 is 29. 29 times 6, that's 174. Then after that, you can finalize using your calculator so that you can get the sum, which is 3,210. So the sum of the first 30 terms will be equal to 3,210. Now, to summarize our session which we had today, we were doing number patterns. And on number patterns, we say that we have 3 categories which we will look at. We have the first one, which is the arithmetic sequence or the arithmetic pattern, which we only look and we only see that this is an arithmetic pattern since it has the first constant difference. We have the quadratic sequence, and the quadratic sequence only has the second constant difference. Then we have the last one, which is the arithmetic ratio, which is the geometric sequence. We only have the constant ratio. Unfortunately, in this question paper, we didn't have a question about the geometric sequence. I hope next time when we are doing another question paper, we'll meet that one. But that one on the geometric, we said earlier that it's easy because, for instance, we are given 3, 6, 12, 24, etc., etc. Then after that, they say determine the, given this geometric sequence, I'm just making an example, determine the the constant ratio. Our R, we said it's T divided by 2, T2 divided by T1, which is also equivalent to T3 divided by T2. So we must have the same thing. So when we say 6, our T2 is 6 divided by 3, we get 2. When you say 12 divided by 6, we still get 2. When you say 24 divided by 12, we still get 2. So 2 is our constant ratio. So if they ask you about the constant ratio, our constant ratio will be equivalent to 2. How did you calculate that? We said it's T2 divided by T1. Then sometimes they usually love to ask this silly question which says that determine the nth term. We know that the nth term of a geometric is a Rn minus 1. What is our A? Our A is the first term. So in this small example which I just gave you right now, our A is 3 and our R, we have calculated it to be 2 and n minus 1. Then you have your nth term. They also love to ask this question that calculate the sum to infinity. Yeah, sum to infinity. So the sum to infinity will be equal to A over 1 minus R. What is our A? Our A is 3. What is our R? We calculated it to be 2. Then we end up having 3 divided by 1 minus 2. But I was just making an example. It's not supposed to be negative. The sum to infinity, it must converge. I think we will do more about the sum to infinity when we meet next time. It's so important that you know about that sum to infinity. And I was just making an example of when you are given questions like this, how can you handle them and how can you tackle them. Thank you so much for having me. Thank you so much for listening during the process, during the entire session. I wish you all the best and I wish that you understand. If you have any question, fear not, ask on the comment section, ask on our WhatsApp group, ask also on our Facebook account. We have our Facebook account which is written Yebo Tutor. Please follow us also as well on our Facebook account. Till we meet next time, have a nice day.